Hello friends, hi everyone, welcome back to the channel Sarvani Ideas Quest. So in this video, I will explore how blockchains ensure that all the records just stored within the blockchain are immutable and verifiable. That is meant to be chaining of blocks. Now let us look at these blocks. Some records, okay? These are some records and they are stored in a blockchain and these are split into blocks. So now these blocks are chained together with a linkage system and there is a mechanism of chaining, okay, which ensures not only an ordering of the block, also with the immutability and verifiability of the blocks. So chaining of block has to be ensured with immutability and verifiability. Now by looking into this diagram, say me how exactly you guys can define the relationship between these adjacent blocks. And answer for that is cryptographic link. Okay, so this link is present between the adjacent chains so that each block in a blockchain will be included using this link. By using this link, what it defines is a cryptographic hash of the previous block. As I already said, each block contains the hash of previous block also. That is what known to be cryptographic hash of the previous block, as they are linked with the linkage system known to be cryptographic link. That is what it's known to be cryptographic hash. Also, it includes with a timestamp. Timestamp in the sense, whenever the block was added to the transaction, that particular time, that is known to be timestamp, that is also included into the blockchain. And in the case of Ethereum, the transaction data will also be included. Okay, so now I say if any individual transaction which makes up a block, okay, any individual transaction making a block, and the block has been modified, then the hash of that block will be very different, right? Hash of that block will be very different from what the hash it is previously. Okay, particularly now think it is your block. For this block, original hash is hash 0 ABC. Now when you do modifications to this block, accordingly the hash will be completely different to its original value. Okay, we can't identify by its old value. Okay, hash will be completely different from the old value. This is the way the cryptographic link works. Okay, the cryptographic link between the adjacent chains, adjacent blocks will be broken. So now thanks to the cryptographic link, because any transaction data in the block can't be altered after the fact. Okay, I already said once the data which is entered into the blockchain, that cannot be altered. So any transaction data in the block can't be altered after the fact. Now if any node can try, like any node will try to verify the entire blockchain. Okay, now by trying to verifying this entire blockchain by producing the hash of the very first block, and then we have to make sure that those hash contains the present in the second block also. Okay, and then we have to keep repeating this process until all the blocks have been verified. Okay, and if you now like say if you want to change the contents of one transaction in one of the previous blocks of blockchain, okay, when you want to change the contents of the transaction in one of the previous blocks of blockchain, then you need to recompute the hash for that. Okay, we have to recompute the hash. Also, when we recompute the hash for that block, then you need to include that modified block hash. Okay, we have to include that modified block hash where? In the next block as well. Fine. So for the next block, if the hash of the previous block is changed, then its own block hash will also be different, right? So the hash with that block will also need to be recomputed again. This is what the fact. If you wish to change any transaction, any previous transactions between the blockchain, then you will need to recompute the hash for each and every single node. That is what I am trying to say. Sorry, single block. Okay. So this is something which is a consensus, right? Which is not trivial. Which is not trivial because you need to reach a consensus among all these applications, among all these nodes, right? So all the nodes which are participating in the blockchain, they have to reach to this consensus, and that is not trivial. Which is meant to be, trivial is meant to be except of altering of all the subsequent blocks, which is complicated and requires a consensus, right? So this state of consensus is neglected, which is not almost impossible. Okay, consensus is almost impossible, which is why we are saying that blockchain has to be ensured with the immutability and verifiability. This is the use of cryptographic link, which ensures that every single transaction, the blockchain is both verifiable and permanent. That is need to be immutable. Okay. So, which is why we can also define a blockchain is a decentralized ledger. Yes. A blockchain is a decentralized ledger that can record transactions in a manner that is immutable and verifiable. Okay. Now let us break down this definition into some components. Okay. So blockchain is a distributed ledger, right? A ledger can be considered to be any sequence of records. Ledger is a sequence of records. And the records which are stored in the blockchain, these are distributed across multiple nodes, right? These are shared across multiple nodes. Sorry, stored. Stored across multiple nodes of blockchain. Okay, multiple nodes in the sense nodes which participate in the blockchain network. As for the contents of these records, okay, now for the contents of these records in the case of Ethereum, I think, okay, first I represent with Ethereum, right? So in the case of Ethereum, not only with Ethereum, I can say in most of the public blockchain networks, this will record a collection of transactions, okay? Record the collection of transactions, and the properties of these transactions include the fact like they are immutable and they have to be verifiable, right? Immutable, and if any change is made to be any already recorded transaction, okay? If the change was made to any already recorded transaction, that can be detected by the other participant as well immediately, right? Participants in the blockchain network who participate in the Ethereum or particularly in Bitcoin, Zcash, whatever the blockchain may be. Okay, so these nodes will then be able to disregard the things, disregard the chains, and stick on with that original version, right? Original version of the transaction. Hope you guys getting my point. So the transaction information can also be verified. It can also be not only to be able to verify it, okay? It can be verified, not only be able to verify that the transaction cannot be altered. You will also, like, we can see this soon, just later. Okay, I will be confirming with the course. Now we can verify that a transaction is indeed, we have to be verified the transaction is indeed a valid one before it get added to the blockchain. That is what it will be immutable. Okay, so in this video we have covered the fact like immutability and verifiability of the blockchain transactions have been assured thanks to the cryptographic link existence, right? So with this link to the previous block, which is included to every block of blockchain, the hash will be recomputed. By this, each and every node will get to know whenever the blockchain hash was changed. Yes, so that is what about chaining the blocks. Fine. Hope you guys understand the clear topic of this, and still if you have any doubts, please feel free to comment me below. Sure, I'll be answering for you there. Thank you.